My apologies to the online people because I have to turn on the camera before I connect this thing. So let's see if we can make it go faster this time. So back to the classroom computer. Yes. Come back to this one.
No, and I, of course, the trouble is, I'm something. I don't think I've ever tried.
Said it couldn't connect, so we press this again. That should do it.
Pretty much.
Let's see what happens. All right. It looks like it's working. Good. Open your books to page 80, 2.3. Thank you again for 82% of you reading the pages before we started the section last time. I hope we have a high rate doing the same thing this time. let's excuse me, let's pray. Father, thank you for this time we have together. I ask your blessing on these students as we work this material. Help them to understand it. Help me to explain it well. In Jesus' name we pray. Amen. Okay, today we're drawing pictures. No, they're not pictures, they're Venn diagrams. So, question number 1. I know it's yours, but based on past experience, you need all the help you can get. So I'm going to do one of your problems. Draw a Venn diagram to illustrate the relationship among the sets U, 1, 2, 3, 4, 5, A, 1, 2, and B, 1, 3, 5. You can look at page 75 in the textbook and see what's going on. So I'll just say number 1, I'm going to draw 2 circles and a big square. Whoa. And I'll call this A, this is B, and this is the universe. Okay? Now, what's in A? 1 and 2. And what's in B?
1, 3, 5.
So 1 is in both of them, and 2 is out here, and 3 and 5 are out here. Everybody see what I did? 1, 2, 3, and 5. A is 1 and 2, B is 1, 3, and 5. So where they intersect, 1 is in both A and B. And then the universe has 1, 2, 3, 4, 5. There's 1, 2, 3. 4 is missing, so I put 4 down here in the corner. 4 is in the universe, but it's not in A and it's not in B. Yes.
Do you put the squigglies around the 2, the 1, like the numbers? Or is it okay not to do that?
All you're doing, anything squiggly here is just the old guy shaking.
Okay.
If I could make straight lines every time, I would. And the circles would be perfect circles, just like in the book. Okay? So because we're doing Venn diagrams. So in the last section, we were doing those little braces with numbers in them. We're not doing that in this section. This is a different thing. Drawing circles and putting the numbers in circles. Okay, let's do number 2. Do the same as in problem 1 for the sets universe, A, B, C, D, E, F. A is A, B, C, and B is D, E, F. So here's A, here's B, and what's in A?
A, B, C.
A, B, C. What's in B?
D, E, F.
D, E, F. And there's nothing in there because why?
Oh, no one.
There's no element that's in both A and B.
Yeah.
Then I draw my box for, whoa, maybe I can come over like this and down, that'd be better. Who knows why that's that? Oh, it erases the whole box. Now, let's see. There. And that's the universe.
A, B, C, D, E.
And what's in the universe?
A, B, C,
All of
D,
them.
E, F.
A, B, C, D, E, F. So is there anything to write down here in the corner?
No.
No,
Oh, really? Oh,
because A, B, C, D, E, F is already in there.
okay.
Everybody see what's going on?
Yeah.
Well, good. Now, it could be that this is so foreign to some of you in terms of your past math experience that even though we're working these here, you might want to go home and work them again just to practice doing this stuff to fix it in your head. In problems 3 through 8, draw a Venn diagram and shade the region representing each specified set. So number 4 says A prime union B prime, or A complement union B complement. You know what A complement means?
Everything's not
Everything in the universe that's not in A. You know what B complement means?
Everything that's not B.
Everything in the universe that's not in B. And you know what union means?
Combine them.
Combine those two, put them together. So I'm going to make a circle for A and a circle for B. Going to draw a box around it. Well, come on. Get those lines straight. Okay, and that's the universe. All right, now I'm going to try something here. We'll see if this works. I'm supposed to shade regions. So the complement of A would be, let's change to green, would be everything. Whoa, how cool is that? Can you see that green up there? It's everything outside of A. Everybody see that? The complement of A? Okay? And then the complement of B, let's pick another color here, is what?
Everything.
Everything outside of B. Whoops. Yeah, let's do that one, okay? So,
Bless you.
okay. So get out of here so I can do this work. There. Okay, everybody follow what I've got up there? Red is the complement of B. Green is the complement of A. Now union, let's go back to black here. Union would be where you put all the green and all the red together. Right? If it said intersection, now watch this. If it said intersection, you would only take the part where you have both red and green. Everybody see that? Intersection would be where the red and the green intersect. But union means any place you have red or any place you have green, so you're supposed to shade that in. So let's shade this in. So that means we're going to shade in everything except this little section right here. Do you see that? So how do I do that? Just shade it like this. Is that messy or what?
Now what are we doing? How do
Any place there were red lines or green lines, because it's the union of the red with the green, the union of green and red. So any place where there's red lines or green lines, I shade it in.
Because you combine them together.
Because I'm combining those two. Okay? So I'm shading in everything except this little section right there in the middle.
So that's
And you say, that is a mess. Yes, it is. But that's how you do it.
like that?
Okay? Let's jump down and do number 8. 8 says, so I draw my picture. Here's A, here's B. Put my universe around the outside. And the union of A and B, let's change that color, would be right?
Yeah.
Putting A and B together. And then, what do I want to subtract from this part that's shaded in red?
A.
I want to subtract A. So, let's change to this color, see what that color gives me. So that means I'm going to take everything here away. Everybody see that? I'm subtracting A. So what am I left with? What does that
You're left with B.
What does that equal? All of B or just this part of B here? With that little slice out of it. You see that? Because I'm subtracting A, so I have this with A taken away, so that means I shade in all of this and leave that little spot right there open. Okay? Do you see that?
No.
Do you see where I got the red lines?
Yes.
Okay, so the red lines are the union of A and B, agreed? Then I'm going to take away A. So here's A, so I'm going to erase A from it. What's left? That part of B without that little chunk on there that was overlapping A. Do you see that? Now, if this is brand new information, you're probably going to have to look at it 2 or 3 or 4 times to make it stick. Because we have a test next Friday. We cover 2.4 on Monday. We do the chapter review on Wednesday. And then a week from today, we take a test over this chapter. Over all 4 topics. In problems 9 through 17, use the numbered regions of the diagram below to identify each specific set. So what's 10 say? C intersect the union of A and B. Everybody follow what we just wrote down here? Now, what's the union of A and B? What numbers are inside A?
1, 3, 5, and
Does everyone see 1, 3, 5, 7? What numbers are inside B?
2, 3, 6, 7.
Everybody see 2, 3, 6, 7? What happens if I unite those? What do I get?
1, 2.
1, 2, 3, 5, 6, 7. Is that right?
Yeah.
Everybody follow that? Now, what's C? What numbers are in C?
4, 5, 7, 6.
4, 5, 7, 6. It doesn't matter. The order doesn't matter. So now I'm supposed to do intersection. Do you remember what intersection means? No? Then look at your notes. What? What's
Common element.
What's in common? So what's common to both of these?
5,
5,
6, 7.
6, 7.
5, 6, 7. So that's regions 5, 6, and 7. That's the answer to question number 10.
Can we put that answer in brackets?
No, you don't have to put it in brackets, because that brackets is for the stuff in the last section we were doing. Here we're just talking about regions. Number 12. Okay, everybody, can you read what we have written here for number 12? A intersect B prime. So what's in A?
1, 3, 5, 7.
1, 3, 5, 7. What's in B prime?
1, 5, 4, 8.
1, 5, 4, 8. Everybody see where you get 1, 5, 4, 8 for that? The complement of B, everything in the universe that's not in B. Then what's the intersection of those? 5.
5 and 1, actually.
Oh, 5 and 1. Well, let's put them both in there. 1 and 5. Okay. Now let's go over here. What's in A? 1, 3, 5, 7. What's in C prime, the complement of C?
1, 3, 2, 8.
1, 3, 2, 8. Everybody see that? Now, what's the intersection of those two?
1, 3.
1 and 3. Now, I take this, and what do I do with them?
1,
Union,
1, 3, 5.
combine them. So what do I get?
1, 3, 5.
1, 3, 5. Regions. 1, 3, and 5. That's all there is to it. Are we having fun yet?
No.
No, we're not. So, let's do something else that's not any more fun than what we've done already.
Right.
This is disgusting. Is it time to count to 3 again?
Can we yell it instead of saying it?
Probably. For each section that you do, every new kind of problem, you just need to count to 3 and get over it. and then move on.
Can I ask a question?
No.
What?
What is the difference between an element and a subset?
An element, like if I had the set 1, 2, 3, 4, elements of that are 1, 2, 3, and 4. What does that say?
1, 2.
The set 1, 2, is that a subset of this set?
Yes.
Because the elements of this set are in the elements of this set. So when I have this symbol, it's going to be a subset, isn't it? When I have 1 by itself, it's going to be an element.
Okay.
Number 18. Draw a Venn diagram to illustrate each specific set. I want X to be an element of A, or what's the other condition?
An element.
X to be an element of B. So here's A, here's B, here's my universe. X is an element of A. Let's use red for that one. Or X is an element of B. Well, that's not what I wanted. Let's use this one. No, let's use this one for that. Well, that's not it. Okay, let's use this one. Can you see that blue up there? So now I've got X is an element of A in red, or X is an element of B in blue. Now, or, let's go back to this. Or. What does or mean? Union or intersection?
Union.
If it can be this or that, what would that be? This or that would be union. So or equals union. Put that in your notes. It's on page 64. Or is union and is intersection. So if I'm going to unite these two together, let's use green for that. If I'm going to put the red and the blue together, what's going to be green? Anything that's red and anything that's blue. You follow that? Still messy any way you look at it. Say, I need to get me a box of colored pencils.
Basically.
Okay. Let's move down to number 20. Oops. Go back to my regular color again. What's the condition here? X is an element of what? A. And X is not an element of B. So I draw my two circles. A, B, draw my universe.
You might want to put a cross in that E if it's not an element of B.
A is not an element of B. Yeah. Make a mistake when you're copying it down and you'll miss the problem, won't you?
Cross out that
Good. So, to make X an element of A, that would be All of this, agreed? To make X not an element of B, that would be everything in the universe except B. Everybody follow that? Can you see those red and green lines up there? Now I'm looking for and. What is and? Or was union, and is intersection. Where do the red and the green lines intersect?
In A.
Is that blue? No. Is that blue? Purple. Okay, I'll use purple. So every place I have red and green, I color it purple. And do you notice? I don't color that little Pac-Man bite out of there, because it doesn't have green in it. It only has red. Okay? Well, that's enough of that.
Yeah, it is.
Whoa. We're only halfway through class and your brain's throbbing like there's no tomorrow. Welcome to the world of Venn diagrams. And if you've seen these before somewhere, your head doesn't hurt as much. If you've never seen them, your head is throbbing like it's going to explode. It will not explode. Relax, I promise you. Just keep on moving. But understand that as we keep going, your brain is going to want to shut down on you. So you might have to, on your own, break your study time up in little 30-minute sections and then watch part of the video and watch part of it again to get this stuff down. But remember, if your head's throbbing right now, it's because someone failed to teach you any of this stuff in your past ever. And all I can say is shame on them. This is such beautiful stuff. This is like saying to somebody, you've never been to the Nelson Atkins Museum of Art? You've missed out on all of this world's beauty? I've been there, but I don't go back because math is so much more beautiful. Oh, you go. You're making me sick to my stomach now, along with my headache. Okay, let's move down to number 26. 26. Whoops. Don't need any of that fancy stuff. Draw a Venn diagram that satisfies this equation. A intersect B equals what?
0.
Empty set. So I draw an A, I draw a B, and I put a box around it for my universe. Why aren't they intersecting? Because it says the intersection is empty set. So I took where they overlapped and separated them. I've just drawn a Venn diagram. I've just drawn a picture of what 26 says in mathematical symbolic language. Do you feel powerful? Let's do 28.
Shape with the language of English.
Let's do 28. So now I have A, B, and C. So I have 3 circles. Here's A, here's B, and here's C. See, why'd you do that? Well, I'm used to making A and B together. And why did I put C out here in my universe?
Because it doesn't connect.
Because the intersection of this with this is empty set. You see that? So I put A and B together, and it doesn't intersect with C, so I stick C out here just hanging out by itself. Well, actually, this is kind of easier than the previous section, isn't it?
Okay, now that you did all the zeros, can you do one that is 27 or 29 just to show us?
Okay, let's do 27. What does 27 say? A intersect B equals what?
B.
So when I put inside my universe, when I put my circles for A and B, and the intersection of A and B is B, here's A. What would make the intersection of A and B equal B?
They were the same circle.
If B
Yeah.
was inside, right? So where do they intersect? At B, because B is inside of A. Good question. In problems 30 to 34, use the numbered regions in the diagram for 9 through 17. So we're back to that picture on page 80. Number 30. Use the diagram to verify each equality. 30 says A union B equals B union A. Okay, look at the picture on page 80. What's the union of A and B? 1, 3, 5, 7, 6, 2.
Yeah.
1, 3, 5, 7, 6, 2. Everybody follow that? Just take your pencil and say circle A, circle B, unite them, put them together, and what regions what numbers do you get? 1, 3, 2, 5, 7, 6.
What about 7?
He said 7.
Did I say 7? 1, 2, 3, 5, 6, 7. Now let's look at B union A. So circle B first, then circle A. What do you get?
Same thing.
1, 3, 5, 7, 6, 2. Same numbers again, right?
So they are equal.
So they're equal. There you go. That's how you've verified they're equal, just by putting that stuff down there.
Okay, that seems easy.
Okay, that was A. Let's do B. A intersect B equals B intersect A. Okay, look back at the picture on page 80. Where do A and B intersect?
3, 7.
3 and 7. See, are we feeling powerful? You go, hey, my headache's going away. I'm starting to see this stuff. Where does B intersect A?
3, 7.
3 and 7. They're equal. Now, look at problem 30 and read what you just did. These two equations are called the commutative law for set operations. A commuter train goes back and forth, just like in arithmetic. 6 plus 3 equals 3 plus 6. A intersect B equals B intersect A. A union B equals B union A. Is that like being at the Nelson Atkins Art Gallery and looking at a Monet and saying, that's the commutative property of set operations?
No.
See, I'm thinking they ought to have a section called Mathematical Beauties. And then put stuff like this up there so people can stand there and ponder it like they do all that other stuff. That doesn't seem strange to me. Number 32. A union, parentheses, B intersect C equals A union B, in parentheses, intersect, wow, A union C. You go, whoa, that's way too much stuff. No, just take it one at a time. What's in A?
1, 3, 5,
1,
7.
3, 5, 7. What's in the intersection of B and C?
6, 7.
6 and 7. Everybody see that? What's the union of these two sets? These two sets of regions?
1, 3, 5, 6, 7.
1, 3, 5, 6,
Wait, intersection
7.
of B and C is 5, 6, 7.
The intersection of B and C is what?
5,
No.
6, 7.
B.
Is-
Take your pencil and circle B.
Okay.
Now take your pencil and circle C.
Oh, okay, 6, 7.
You remember how I was telling you before? You got to take your pencil and touch this stuff, or your eyes are going to roam around and pick up extraneous information. Focus, focus, focus. And having your pencil touch it
So,
actually helps you keep your eyes from wandering outside of that. Okay,
so,
now
so,
let's go.
So you would make the circle around A first, and then B, and then C?
Okay, see that parentheses around B intersect C
32.
in the problem? See that parentheses around? So we did A, didn't we? So do you see A was 1, 3, 5, 7? Circle A, just circle A.
Okay.
And what's in A?
1, 3, 5, 7.
Okay, so now we've done that one. Now, see that parentheses around B intersect C? What's in B? Okay, tell me what's in B.
2, 3, 6, 7.
So I'm going to put it up here. 2, 3, 6, 7. What's in C?
4, 5, 6.
4, 5, 6, 7. Where do they intersect?
5, 6, 7.
6, 7. Now, you see what I'm doing? See how this is how you show your work? So that even in your own mind you can see what you're doing? You just write this stuff on there. I know it's messy, but it's the way to let you see what you're doing. So now what's the union of these two sets of regions? 1, 3, 5, 6, 7. Now let's go to the other side. Now, what's in A?
1, 3, 5, 7.
1, 3, 5, 7. What's in B?
2, 3, 6, 7.
2, 3, 6, 7. What's the union of A and B?
1, 2, 3, 5, 6, 7.
Everybody agree? 1, 2, 3, 5, 6, 7? Let's go to the other parentheses. What's in A? 1, 3, 5, 7. What's in C? Circle C. What do you see?
4, 5, 6, 7.
4, 5, 6, 7. What's the union?
1, 3, 4, 5, 6,
1,
7.
3, 4, 5, 6, 7. And what's the intersection of those two?
1, 3, 5,
1, 3, 5, 6, 7. Ah! Ah! How cool is that? Put that in the Nelson Atkins Museum of Art, because that is an example of the distributive law of operations. Cool. Okay. Problem 36. Problem 36. Refer to the diagram for problems 9 through 17. That's that picture on page 80 again. The set of regions, 1, 2, 3, and since they said the set of regions, 1, 2, 3, represents which? So now 36, I have A, B, C, D, and E for choices. This is a good way to get ready for the test. Now look at the picture. Do you see 1, 2, 3?
It's an A and B.
I'll draw it up here. One, 3, 2. Everybody see that? Regions 1, 2, 3. Right there at the top of the picture. Everybody see where those are in the picture? On page 80. Regions 1, 2, and 3.
Yeah, okay.
Now, does A union B intersect C represent this region? Now watch, if I put A and B together, that would be all of this. And if I put where it intersects C, that would be this region right here. Is that what I have up here? No. So it's not A. You with me?
Mhm.
Let's go to B. What does B say? A union B intersect the complement of C. So let's draw a picture of it. Here's A, here's B. Union would be put them together. Here's C. And I want the complement of C.
So it would be.
So that's everything in the universe outside of C, which is this region here, and this region here, and this region here.
That one's right.
Oh, does that look like my region up here?
Yeah.
Aha! B is the correct answer.
Yeah, it is.
But you see what would happen? If it wasn't B, then you would try C, then you would try D, and if none of those work, then you would say none of the above. All right. You know what? I want you to stop when you get to problem 37, because as much as I would like to do some applications, if you want to go ahead and do the applications just for fun, because you've seen this stuff before, you're welcome to. But for the benefit of all of those who haven't seen this before and they had a headache 20 minutes ago, let's stop at 37. That's all you're responsible. In other words, if you just learn the mechanics of this stuff, then you've missed out on all the fun applications. But if you haven't seen it before, nailing the mechanics down is more important than doing applications when you don't understand the mechanics of it. So that way, if we stop at 37, then maybe you say, you know, it wouldn't hurt me to work those problems twice, because that's not any more problems than what I've been working when I've been doing 70 of them for another assignment. You like my rationale?
Yes. Thank
All
you.
right. Nothing helps more than to have reasonable people give you a reason to do something.
Agreed.
All right. So I'm going to turn all this stuff off, and I'll be available between now and chapel to answer your questions.
Sorry for missing them.
Yeah.
Very busy and stuff. Now, never.
I give
my
You
own
did.
time. Like I had a paper 2 days ago.
Yeah. When in doubt, hit the turn off button.
Reffing has actually been taking a toll on me.